All right, today we are pulling back the curtain on something that keeps countless communities safe every single day, but most of us never even know it's there. We're talking about process safety management. And to help us break it all down, we're using the ammonia refrigeration standard from Land O'Lakes as our guide. Let's get into it.
So, think about it. You know those industrial facilities you drive past every day? Food processing plants, giant cold storage warehouses, places like that. Well, a lot of them rely on some seriously powerful chemicals to get the job done. Chemicals that are essential, but also could be a huge risk if they're not handled with just extreme care.
And this is a perfect example. Anhydrous ammonia. It is fantastic at its job, a super efficient refrigerant that makes large-scale cooling possible. But here's the thing. It's kind of got a double life. Both OSHA and the EPA classify it as a highly hazardous chemical. So the whole game is about harnessing all those benefits while completely neutralizing the risks.
And this is why it's such a big deal. The absolute worst-case scenario is what's called a catastrophic release. And believe me, we are not talking about a small leak here. This is a massive, uncontrolled event, an emission, a fire, maybe an explosion, that puts everyone nearby in serious, immediate danger. We're talking about employees inside and the public outside. This is the one thing this entire system is built to prevent.
So, it's helpful to think of it this way. For a lot of us, anhydrous ammonia is kind of a hidden chemical neighbor. You don't see it, you don't know it's there, but its presence demands a really specific and robust set of rules to keep everybody safe.
And the risks are no joke. A release poses a threat on 3 different fronts. You've got serious health hazards if you breathe it in or touch it. You have physical dangers, like the risk of fire. And on top of all that, it can cause long-term damage to the environment, the air, the soil, and the water. The stakes are just incredibly high.
So how in the world do you manage a neighbor like this? Well, you don't just cross your fingers and hope for the best. You create a detailed safety playbook, a playbook that's not just a good idea, it's actually mandated by law.
And that playbook has a name, Process Safety Management, or PSM for short. This is a federal requirement from OSHA, and it's designed specifically for managing processes that use highly hazardous chemicals, just like ammonia. This is that invisible shield we were talking about.
You know, what's really interesting here is how these goals all stack on top of each other. Of course, priority number 1 is preventing a disaster. But the program is smart. It knows you can't do that just by checking boxes. You have to protect people, you have to follow the law, but the real ultimate goal is to build a culture where safety isn't just a list of rules, it's the most important thing to everyone, all the time.
So what does this safety blueprint actually look like when you get down to it? Well, we can basically break down any solid PSM program into 3 main parts.
First things first, you have to know your system inside and out. It's just common sense, right? You can't protect yourself from a danger you don't fully understand. So the whole first part of this blueprint is about building a rock-solid foundation of knowledge through some serious documentation and analysis. This foundation starts with something called Process Safety Information, or PSI. Just think of it like the complete technical encyclopedia for the entire system. I mean everything, from chemical data to equipment specs. Once you have that encyclopedia, then you can do a process hazard analysis, or a PHA, and our guide document calls this the heart of PSM for a reason. It's where a team sits down and systematically brainstorms every single thing that could possibly go wrong and then figures out how to stop it.
Okay, so once you know the system and all its risks like the back of your hand, part 2 of the blueprint is all about actively controlling the process, day in and day out.
And a huge piece of this is something called management of change, or MOC. Think of it as a super strict gatekeeper. Before anyone, and I mean anyone, can change anything, a pipe, a valve, a line of code, it has to go through this formal review to make absolutely sure that the change isn't going to accidentally create some new, unexpected danger. Control also means having crystal clear operating procedures for literally every situation you can think of. And this really shows you the proactive mindset of PSM. A huge focus on what's called mechanical integrity. This isn't about fixing things when they break. No, this is about a relentless schedule of inspections, testing, and preventative maintenance to make sure they never break in the first place. All right, and finally, a great safety plan is useless if it's static. So the third part of the blueprint is all about making the system dynamic. It's about building in a process to constantly learn and get better.
This happens through this really powerful feedback loop. Now, this is crucial. Investigations aren't just for when something bad happens.
The system requires an investigation for any incident that could have led to a disaster, what we call a near miss. These are treated like absolute gold because they're chances to learn, and that proactive learning is then backed up by tough compliance audits every 3 years, checking every single part of the program to make sure it's actually working.
Now, all these systems, all these procedures, they're absolutely critical, but they're nothing without the people running them. Which brings us to the human element, where everyone, and I mean everyone, has a role to play.
So at a high level, you have a couple of key roles. The PSM manager, they have the overall accountability. The buck stops with them. Then you have the PSM coordinator, who's deep in the details every day, managing the paperwork, tracking the deadlines, and just keeping the whole system humming along. But look at this. The responsibility goes way beyond them. It's on every single person on that site, even outside contractors. Everyone is expected to follow the rules, report any hazard they see, and be part of the training. See, safety isn't just one person's job. It's baked into everybody's job. And this brings us to our final and maybe the most important point of all. A program like this is never finished. It's a constant, never-ending watch.
Our source document uses the perfect phrase for this. It calls it a living system, and that's exactly what it is. This is not some binder that you write once and then it collects dust on a shelf. It's a dynamic process that needs constant attention, constant feeding, and care to stay effective.
And this timeline shows you exactly what that constant attention looks like. You've got annual checks on schedules and status. You have internal self-audits every 2 years just to find ways to get better. And then every 3 years, you have that huge, formal OSHA compliance audit. It's a cycle of checking and improving that just never stops.
In the end, it all comes back to this one quote from the purpose statement of our guide. It's not just about the rules. It's not just about the equipment. It's about building a strong culture of safety. And that takes everyone participating, communicating clearly, and having leaders who are 100% committed. That's the glue that holds this whole invisible shield together.
Process safety management is just a powerful example of one of these systems working tirelessly in the background to stop disasters before they can start. It really makes you wonder, doesn't it? What other invisible shields and safety systems are out there quietly protecting us in ways we never even see? Thanks for joining me.